All right, guys, just give me a thumbs up if you guys can hear me. Just give me a thumbs up, please. Strange scenes going on. For some reason, don't seem to be connecting. So, all right, good stuff. Fantastic. So we're on. We're good. All right. Great to see you guys. And welcome to today's 8th tutorial, where we'll be continuing what we were looking at last lesson, which was surds. Okay. You guys were fantastic last lesson. Good. All right. I can see that you guys can hear me. Good stuff. And hi, David. Welcome to those of you guys who always come here and support. Hi, Natalie. Hi, Finn. David, Graziella. Thank you very much, Stuart, who is the founder of ExamSolutions. He's going to be in the live chat to help you guys out. As I said before, you guys were fantastic last lesson. We want the same type of participation as before. We're going to be going through another type of operation, which is rationalizing surds today. So yeah, let's just go ahead and get straight into it, okay? So let's go for a quick recap of last lesson. So last lesson, we looked at operations with surds, the rules of operations, namely multiplication, division, and this really interesting one, which says that if you take the square of a surd, you get the actual integer value underneath the root sign, okay? So we looked at a couple of examples. For example, multiplication, the square root of 3 times by the square root of 2 using rule 1 would simply be the square root of 3 times by 2, which is equal to 6. We also looked at division, okay, which just uses the same rule. However, if we have an integer term multiplied by the surd, we of course need to divide the integer by the integer. So 6 divided by 2 is equal to 3. And the square root of 8 divided by the square root of 2 using the second rule here would be equal to the square root of 4. Okay, so we get 3 times by the square root of 4, which is 2, which is equal to 6. And the last property, we just use an example to prove that, yes, indeed, when you take the square of a surd, you get an integer value. So that's interesting. We're going to see how interesting that is later on. We also looked at adding and subtracting surds. Okay, remembering that you can only add or subtract like surds. Okay, these are like because we have the same number underneath the square root sign. So we can subtract 2 minus 5 to get negative 3 root 3. Remembering we're not adding the values underneath the surds, underneath the root signs, okay? And lastly, we looked at simplifying surds, okay? Which the idea of simplifying surds is to basically take a value out of the root sign, and which would have the effect of reducing this actual value here, 60, okay? So what we did was we split up the number into a product of factors, remembering that you really want to split it up into a factor where at least one of them is a perfect square. So 4 is a perfect square, so that's why we've chosen 4 times by 15. The square root of 4 is equal to 2, and that allows us to simplify. Okay, you cannot simplify a surd if its factors are not perfect squares. Okay. All right, so we're going to use all of these rules that we learned last lesson and all of these properties to do some more questions. Okay, so I'd like to see how you guys are able to apply what you learned last lesson to these questions. Okay, and just as before, if for example you had 6 root 5, just type in 6 or 5. Okay, so let's get going for the first question. All right, so write the square root of 45 in the form k root 5, where k is an integer. Let's see who's first off. Free root 5 straight in from Ella, there she is, and Natalie. They seem to be just constantly battling those guys. And Jana, welcome. Free root 5, well done. David and Din come in with free root 5. Does anyone disagree? Anyone disagree? Everyone agrees with those guys? I would agree that they are indeed right. Okay, so looking at the question, we've been asked to write the square root of 45 in the form k root 5. Thanks, Graziella. Where k is an integer. So the form they've asked us is actually a form where we well, the value is the value we end up with underneath the root sign is less. Okay, so we need to take a value out, which suggests that we need to simplify the surd. Okay, so simplifying, we split 45 into a product of factors where one of them is a perfect square, 9 is a perfect square. So using the first rule of multiplication, we can split this up into a product of surds or radicals, and the square root of 9 is equal to 3, so therefore our answer is 3 root 5. Well done, guys. Very, very quick indeed. Let's have a go at this question. Expand and simplify 2 plus the square root of 5 multiplied by 7 minus root 5. So this is no different from what you've done before. I believe we've all expanded brackets. We're just doing it with surds and integers this time. Let's see what you come up with. Who's the first one? Answer is 5. Warzone Moment says with confidence. Okay, we'll find out soon. Natalie says 9 plus 5 root 5. Anyone else? Din agrees with Natalie. David agrees with Din and Natalie. What else? Ella agrees with Din, David, and Natalie. So we seem to be getting some concurring views, if that's a word. And Jana, okay, good stuff. All right, let's have a look at the question. Okay, so we've been asked to expand and simplify. Okay, so the rules don't change, right? Expanding out the brackets, we need to multiply 2 by 7 and 2 by negative root 5. And we also need to multiply the square root of 5 by 7 and the square root of 5 by negative root 5. So expanding out the brackets, 2 times by 7 is equal to 14. 2 times by negative root 5, we get negative 2 root 5. And 7 times by root 5 gives us 7 root 5. Taking the square root of 5 and multiplying by negative root 5, got to be careful with the signs, okay? We still get this 5, yes, as we saw in the third rule. However, we can't forget this negative sign, okay? So just evaluating this expression, our final answer is 14 minus 5 is equal to 9. Negative 2 root 5 plus 7 root 5. We have like surds here, so we can add these surds. Okay, so negative 2 plus 7 is equal to positive 5, giving us an answer of 9 plus 5 root 5. Natalie, first in, but well done to everyone getting those in. Very, very well done. If you don't understand anything, by the way, feel free to ask a question. We've got the more than able Stuart Sidders, who is going to be helping you guys out today. Okay, so the next question. All right, so this one's, let's see how you guys get on. So work out and simplify the square root of 64 divided by 2 root 2, leaving your answer, that should say in the, should add that. Let's see if I can change that. Should say in the form a root b, where a and b are integers to be found. All right, let's just change that to nice and blue there. Wow. Okay, by the way, these are non-calculated questions, right? Non-calculated questions. So I've seen some really sharp answers here. You know what? Potentially quicker than I would be able to calculate this by hand. You guys are really quick. By the way, today's a non-calculated day. No calculators for the whole day, yeah? So put your calculators away. Just your pens and papers, please, okay? So we've got Graziella coming in with 4. And she says, never mind, okay? I won't mind that. Natalie, 2 root 2. Ella, the same. Din. We're all speaking the same language, it seems. Okay, so let's have a look at this question, all right? So this term here can be written as a half. So we can pull out a half times by the square root of 64 over the square root of 2. And what can we do with this? Well, we can use the division rule, which says that this is also equal to the square root of 64 over 2 rather. 64 over 2 is equal to 32, all right? Now, at this stage, you know, we've found another way to rewrite this expression, but it's not in the form that they've asked. They've asked in the form a root b, where a and b are integers. And yes, 32 is an integer, but half is not an integer. Half is a fraction or a rational. Okay, so we need to, it suggests that we need to further simplify this and see if we get cancelling, so that we actually get an integer out front. Okay, so simplifying the numerator here, this square root 32, we rewrite it as a product of its factors, its square factors. So as you can see, I've intentionally chosen 16 and 2 because the square root of 16 is equal to 4. It's a perfect square number. And that's going to give us, splitting these up into a half times by 4 multiplied by square root of 2. Okay, 4 times by a half is equal to, same thing as 4 divided by 2, which is equal to 2 root 2. So the answer is A is equal to 2 and B is equal to 2. So who was first in? Who was first in on that one? Natalie again. Can't stop the girl, honestly. Well done to those guys. Din, well done. Ella, Graziella, well done for noticing your error there and changing it. David, fantastic. And Jana, well done. And we've got some from Warzone again, who says 4 times by 2 to the power of a half. Well, that's I'm not quite sure that's correct there. All right, so let's look at this question. Okay, now if you look at this question really close, right? Some of you at this stage would have noticed that, well, the square root of 64, that's equal to 8, right? And yes, you're right. And you could have continued on the calculations. This is what you'd get. You get half times by 8 over root 2, okay? Which would give us 8 divided by 2, root 2. Okay, so 8 divided by 2 is equal to 4. So our final answer would have been 4 over root 2. However, if you remember the form they asked us, okay, cool. Warzone is apparently correct. Sorry, I'm not looking at that intensely. Good stuff. So yeah, if you would have looked at this as 4 over root 2, this is not the same form that they've asked us to put it in, right? They asked us to get it in a times by root b, where a and b are integers. However, in the denominator, we have a surd, right? So how do we get it in that form? Well, to get it in that form, we do something called rationalizing the denominator, okay? So what we can do is we can make this surd become a rational number. And I'll show you exactly how, all right? But before I do that, I want you guys really close to your keyboards. I've got a question for you. It's not a it's not a trick question. It's literally a question. I just want to see how fast you guys are going to be able to react to this. Yeah. So here's my question. Are you ready? Let's go. All right. What's the square root of 2 over the square root of 2? Who's the first to answer this? Quickly. 1. Good stuff. Natalie again. Good stuff. 1. All right. Very good. Any number divided by itself is equal to 1. Very good. So I'm actually getting to a point here. I'm not insulting your intelligence. The answer is indeed equal to 1, right? Now, we're going to use this, okay? Now, to rationalize this term here, I'm actually going to multiply by 1. But instead of multiplying by 1, I'm going to multiply by the square root of 2 over the square root of 2. Okay? And let's see what we get when this happens, okay? So in the numerator, we simply get 4 times by root 2 is equal to 4 root 2. And in the denominator, we get the square root of 2 times by square root of 2, which is equal to 2, as we now know, okay? Now this here this has been rationalized, okay? We've changed from having a surd in our denominator to a rational number, okay, of 2. And we can then further simplify this to get the desired answer, okay? So this is how you rationalize, okay? It's by multiplying by some value which is equal to 1. Now there's a reason why we chose the square root of 2 in this case, okay? The reason why we chose it was because of this rule here, okay? Which says that the square root, when you square any surd, you just get an integer value, okay? So this rule here really explicitly shows you that when you multiply two surds, you can actually get just an integer value, which is exactly what we were looking for. right? We were looking for an integer value. All right, so you can see explicitly in the calculations why we chose to multiply by the square root of 2. We had the square root of 2 in the denominator, okay? So let's go through a couple more examples quite quickly. I'm just going to show you these before we get you guys onto questions. If you are to rationalize this term, you guys can literally just give me the answers as we go along, as I'm going along explaining it, if you feel you're correct. So rationalize 3 plus the square root of 6 divided by the square root of 3. Right? We need to, in order to rationalize, we need to multiply by the square root of 3 over the square root of 3. Okay? So evaluating the numerator, we get 3 root 3 plus the square root of 18, and on the denominator we get 3. Okay, so this is rationalized. Okay, this is not simplified, it's just rationalized. Okay, you can go ahead and further simplify that. Okay, so anyone who wants to simplify that, go ahead and give me that result. Okay, cool stuff. Next, 6 over 1 plus the square root of 2. All right, so this is a different type of question here. The reason is because we have two terms in the denominator. One term is a value, an integer value, and the other term is a surd. Now, in order to rationalize this term, we need to multiply by what's called the conjugate. Okay, so you get the conjugate of a term of two terms by simply changing one of the signs. Okay, so notice that instead of multiplying by 1 plus root 2, which you might have intuitively done, we've multiplied by 1 minus root 2 divided by 1 minus root 2. Okay, so multiplying the top and bottom and expanding the brackets, we get 6 minus 6 root 2 divided by 1 times by 1, which is 1, 1 times by negative 2, which is negative 2, the square root of 2 times by 1, which is just positive root 2, and the square root of 2 times by negative square root of 2 gives us negative 1, giving us a final answer of 6 minus 6 root 2 over negative 1. Okay, so we have changed, using the fact that we had two terms, we multiply by what's called a conjugate, okay, which is just the negative in this case, right? And we got this, okay? This again can be simplified to give us negative 6 plus 6 root 2, okay? So very, very well done. Good stuff, guys, for getting involved while I'm explaining. And thanks, Stuart, for just checking out those answers. Okay, so here's why using a conjugation is useful. Okay, so imagine if we were to multiply by 1 plus the square root of 2. Okay, this is what we would get. We'd get 1 plus root 2 plus root 2 plus 2, which is equal to 2 plus 1, which is 3. And adding these like surds, we get 2 root 2. However, this is not a rational number as we were looking for, okay? So it's important to know that with these scenarios, you need to multiply the numerator and denominator by the conjugate, okay? So as a rule of thumb, a plus root b, the conjugate of that is equal to a minus root b, and the conjugate of a minus root b is equal to a plus root b. Okay, it's your turn, guys, now. Let's see who's going to be fastest off. All right, let's go. All right, so no calculators as said. Let's rationalize the following expressions, the following term. Who's got it? Four root 5 over 5 coming from Ella. Okay, can we have the answers in exact form, please? Exact form. Okay, cool. So we've got Warzone 4a root b over b. Might be a typo there you got. Okay, answers coming in now. Good stuff. Din, David, and Jana. It looks correct to me. Ella was first in. Well done, guys. Okay, so yes, try and avoid decimals. Nice to see you, Kaz. Try and avoid decimals. Okay, so what we want to do is to rationalize this term, we need to multiply by the square root of 5 over the square root of 5, which simply gives us 4 root 5 in the numerator divided by root 5 times by root 5 is equal to 5. Okay, so very, very well done. All right, this is the last slide, okay? So it's just purely questions. Let's get you guys all involved. Just give it a go, all right? But no calculators. All right, let's go. Next question. 3 plus the square root of 3 divided by the square root of 2. How do you rationalize this term? Pens and papers only. Oh, you thought my 5 was a B? Oh, sorry about that. I tried so hard to make my handwriting as good as I can possibly make it. Who's got this one? So war zone moments, 3 root 2 plus root 5. Okay, so slightly different answers there. Ella comes in with 3 root 2 plus root 6 over 2. Warzone changes his mind. Is it because he's seen the calculations, or has he looked at Ella's and he said, ooh, let me change it? I'm joking. All right, okay, looks like Natalie's got the same thing. Has anyone else got anything? Anyone else? Anybody else? All right, okay, let's go through the answer. All right, the answer is indeed 3 root 2 plus root 6 divided by 2, okay? But let's see how we get there. We need to multiply by the square root of 2 over the square root of 2. It's still the same thing as multiplying by 1, okay? So that's the reason why this final term is exactly the same as this term that we started with. But we're just writing it in a form where we don't have a surd in the denominator. That's all we're doing. That's what rationalizing is, okay? So multiplying out the numerator, we get 3 root 2 plus root 6 divided by root 2 times by root 2, which gives us 2. Good stuff. Very, very, very good stuff. You guys are smashing it right now. Once again, let's see if you can do this question. 5 over 4 root 3. Be interesting to see what you choose to rationalize this. Five over 4 root 3. Okay, so first in we've got Ella Greensmith coming in with 5 root 3 over 12. Same thing for Din. Same thing for Natalie. Anyone else? It looks like the usual. Sorry for not putting a bracket. Oh, bless. All right. Yeah. I mean, yeah, to be quite, yeah. I mean, it's always good to use brackets where necessary. Um, of course, it avoids errors when you're calculating, especially when you're doing operations. Okay, multiplication, division, etc., etc. Okay. So Barvish, nice to see you on 5 root 3 over 12. Anyone else? Anyone else? I'm waiting. Anyone else? Okay. All right. Looks like Stu's giving up the answer away here. He has said well done to Ella. So the answer is indeed 5 root 3 over 12. Very, very good. Okay. So as I said, it's interesting to see what you guys choose to rationalize this term here. Some of you might have said, oh, multiply by 4 root 3 over 4 root 3. Now, that would have also been correct, but it's just a bit longer, okay? We always try and avoid longer roundabout calculations to just avoid errors, okay? So multiply just by the surd only, we get 5 root 3 divided by 4 times by 3, which is equal to 5 root 3 over 12. So fantastic, guys. And I see Finn there as well. Graziella, well done. Good stuff. The next question, off we go. How do we do this one? Let's get you guys all participating. This is a level 6 to level 7 question for GCSE. There are slightly longer, more involved questions which just require just a bit of algebra and rationalizing expressions, but we'll go through that another day in an exam question, okay? So we got 3 minus root 6 over negative root 3, okay? Root 6 over 9, we've got 3 minus root 6 over 3, so slightly different in there from Ella. And we've got din the same as Natalie, with 3 minus root 6 divided by 3. Warzone. Warzone. Yeah, feel free to evaluate the denominator there, Warzone. So 3 plus root 6 divided by 9 minus 6. 9 minus 6 is what? It's 3, isn't it, right? Okay, so as explained earlier, we need to multiply this term by the conjugate, okay? So multiplying by the conjugate of 3 plus root 6 is 3 minus root 6. So multiplying by the top and bottom by this value, we get 3 minus root 6 divided by this term here. Expanding out the brackets in the denominator, you can see that the terms would cancel and we would get 9 minus 6, okay? So our final answer is 3 minus root 6 divided by 3, okay? Let's do another one. It's good practice, guys. Well done. Let's have a go at this one. Let's have a go. So first in there, we've got, I think that was Warzone. Good stuff. So it's always nice to see this good competition. Be not intimidated if you don't get it. Feel free to watch these videos afterwards. Hopefully I've been able to explain the concept clearly enough for you to watch this back and understand it. Good stuff. We're getting good answers in. Any new people? Anyone out there? Anyone? Anyone? David, you good stuff. 3 plus root 3. Barvish, nice. Okay, good stuff. Good to get you in. Very good. All right. So let's check the answer. Okay. So again, we need to multiply by the conjugate. Remember the definition of a conjugate? You conjugate two terms by simply just changing one of the sign. Okay. All right. So changing this sign, we multiply by 3 plus root 3 over 3 plus root 3. Expanding out the brackets in the denominator, we get 9 plus 3 root 3 minus 3 root 3 minus 3, okay? And you can see that the terms cancel, so we get 3 plus the square root of 3 divided by 6. Very well done. And the last question of the day, here we go. How do you do this question? Last question of the day. So this time we've got 2 surds in the denominator. What do we do? Two root 3 minus 2 root 2. 2 root 3 minus 2 root 2. We'll see. Yeah, let's go for the final push. Just give it a go. And it's glad to, feel that no one's using their calculators. I can feel it. All right. Barvish, again, good stuff. Well done, everyone, for getting involved. Anyone else still working on it? Last question of the day. Warzone and Jana. Okay, 2 root 3 minus 2 root 2. Warzone comes in with 2 root 2 minus root 3 over negative 5. Barvish, 2 root 3 minus 2 root 2. David, 2 root 3 minus 2 root 2 minus, okay, divided by the whole is 1. Good stuff. Okay, so let's have a look at the answer for the final answer of the day and let's see who got it right and how it's done. Okay, more important. All right, so 2 divided by the square root of 2 plus the square root of 3. All right, in order to rationalize this term, we need to multiply again by the conjugate. Okay, and the conjugate of the square root of 2 plus the square root of 3 is equal to square root of 2 minus square root of 3. Okay, so multiplying numerator and denominator by the conjugate, we get this term here. Now expanding out the brackets, you have to be careful, of course, We've got a lot of square root signs flying around. Okay, be very, very careful. So the square root of 2 times by square root of 2 is equal to 2. The square root of 2 times by negative root 3 is equal to negative root 6. The square root of 3 times by the square root of 2 is equal to the square root of 6. And the square root of 3 multiplied by negative root 3 is equal to negative 3. Okay, so evaluating the terms in the denominator, our final answer, as these terms cancel, is 2 root 2 minus 2 root 3 divided by negative 1. Again, space reasons. You can, of course, you can simplify this by getting a final answer of minus 2 root 2 plus 2 root 3 as our final answer. Okay, so very, very well done, guys. That was the last question of the day, and I'm just going to pop back on. All right. All right, cool stuff. Hopefully that was enjoyable lesson. Hopefully it was quite an easy lesson, and it's, you know, it's a level. They say it's a level 6/7 part of surds. Okay, so if you guys found that easy, that's great. You know, it'll be a nice, easy way to just steal a few marks in your exams. Okay. I hope you found the lesson useful. Really appreciate you guys coming on. Tomorrow there will be no lessons, and also Stuart mentioned that he'd be doing lessons starting from next week. However, next week's bank holiday Monday, and next week would also be a UK half term. Okay, so we're gonna have a bit of a breather next week. We'll be back on the 1st of June. It would be really good to know what topics you guys need help with so we can go through them in the lessons. We're just really interested in helping you guys out. So we love the support you guys continually give us. It really helps us and encourages us to produce and provide more for you guys. Keep coming, keep showing support. If you're not subscribed to us already, subscribe. If you enjoyed the video, just pop a like. And yeah, we'll be back on the 1st of June. Thank you very much to Stuart for helping us out on the chat. And yeah, as always, I've said enough. So I will see you guys on the 1st. All right, take care, guys. Bye bye.